Hello and welcome everybody to Relations Lesson 4. Today we are looking at domain and range. And I'm going to start off this lesson with a quick numbers system review. I'm going to move through this a little bit quick. You don't need to memorize all of this, but we're just going to talk a little bit about number systems. Before we get going, I want to point you to this symbol here. This little E symbol here, and that represents the phrase belongs to, and we'll see how we use that in on the next page. And these squiggly brackets represent the phase, the set of all. So the set of, oh no, I don't know how I did that now. Set, okay, here we go. Hang on, let me fix it. It's not supposed to pick up my palm. Set of all. If I put my palm on the screen, it's not supposed to pick it up. Okay, so those are two symbols we are going to be using, the little E and squiggly brackets on the next page. The squiggly brackets, if they're kind of a pain to draw, you can use regular brackets, but try to draw them because, they are more correct. I'm not going to take marks off if you can't draw them. So we're going to start with looking at natural numbers. So natural numbers are your counting numbers, right? 1, 2, 3, 4, etc. There are an infinite number of natural numbers. They go forever. And 0 doesn't belong here. So that is the first kind of, the way it's always viewed is, let me scroll up here so you can draw a picture. The way it's always viewed is we have natural numbers, and then the next one we have is whole numbers. So basically it's all natural numbers with 0. So whole numbers encompass natural numbers, but they also have a 0. The next step we go to is integers. So then we go into integers, which are natural numbers, whole numbers because they have the 0, but now we can go in the opposite direction on the number line and we can pick up negative numbers. So then we have integers. And then we move into rational numbers. So rational numbers are numbers that can be expressed as a ratio of 2 integers. So as any number that can be represented as a fraction. So we started off with our counting numbers of 1, 2, 3, 4, etc. And then we got whole numbers, so we added a 0. And then we went to integers, so we went to -1, -2, and now we're at rationals, so we can have, right here, 3 1/2, or here, 1 3/4. So now we have fractions. And then the next one we are going to look at is irrational numbers. So here we go. We have rational numbers that's represented by a Q. And then irrational numbers are anything, it can be any non-terminating, non-repeating decimal, basically. So pi is an irrational number. The square root of 2 is an irrational number. If you do the square root of 2 on your calculator, you're going to get a crazy decimal that goes forever. It doesn't repeat and it doesn't end. So non-repeating, non-ending. Pi we know is 3.14159, and it goes on and it never repeats. So then we also have irrational numbers, which is a Q with a line on top, and all of those are real numbers. So real numbers are rational and irrational numbers. Rational numbers kind of take all of the integers and whole numbers, and then irrational numbers, and combined we've got all real numbers. So all real numbers you can do with an R, or like a pretty fancy R if you can see it there. When I went to school, I learned it was like an R with 2 lines there. It means all real numbers. So out of habit, I still do that. That's just another symbol for all real numbers. So let's get on to domain and range. We will use the number systems a little bit, but for now, I really want to focus on domain and range. So we're going to start with domain. The domain of a relation is a set of all values which can be used for the input or the independent variable. So the domain is all x values, all x values. The range is all possible output values or all possible y values. All y values in a relation. So we're going to look at finding domain and range of ordered pairs of graphs. I think we do, and we do a arrow diagram as well, and a word problem. So most of the time you'll be doing this with graphs, and it's an important skill to have, but we can kind of learn what the domain and range are using the other relations as well, or other types. So I'm just going to put a reminder up here. Domain is all the x values. Range is all the y values. So it says here, list the domain and range of the following set of ordered pairs. So if we're looking at question A, we know that ordered pairs are always written in the form x, y. That means that if I'm taking my domain, it's going to be all my x values. So all my x values are all the first values in those brackets. So 1 and 0 and 3 and 5 and -3. So the way I would write that is the domain is the set, that's my wiggly brackets, of 1, 0, 3, 5, and -3, and then I'll close the bracket. My range is all the y values. So it's a set, and all my y values are 2, 5, 8, 9, and 2. So it's the set of 2, 5, 8, 9, and 2. So it's pretty straightforward. The range is all the y, the domain is all the x, but things can get a little bit tricky with the graphs. I'm going to do B here quickly, and then we'll move on to graphs. So again, my domain is going to be a set, and so is my range. So the domain is the set of x's. So I have, I wanted to go with that one. 3, 0, -3, 2, and -8. 3, 0, -3, 2, -8. Close the bracket. The range is going to be 3, 3 again, 3 again, 9, and 3 again. So I don't have to write that 3 4 times. I can say my range is 3 and 9. Those are the only y values I have in that relation. And the domain lists all the x values I have in that relation. So let's move on to some graphs. So you can see here in A, we have a graph of discrete data, just points. So what we can do is we can say the domain is going to equal, well, what are my x values here? This is 0, -1, -2, -3. So we start at -3 and then we go up. There's a value at, there's a value at -3, there's a value at -2, -1, 0, 1, 2, 3, 4, and 5. So those are all the x values. -1, 0, 1, 2, 3, 4, and 5. So it can get really, really long, you can see. So another way we can write this is domain is equal to, oh, sorry, my dog is playing with another dog. Do you remember our less than and equal to symbols? So hang on, so this is less than. Sorry, that's the dog upstairs dropping a ball off the deck. This is the greater than symbol. And then if you take those and put a little line underneath it, that's less than or equal to. And this is greater than or equal to. So instead of writing the domain as all of these individual values, you can use these symbols to say the domain is the set where x is going to be, I always put the x in the middle, and I say, okay, I put my two symbols in there. So my alligators, and the alligator always wants to eat the bigger value. That's the way, it's the easiest way to think about it. So my lowest limit is -3. So I can say -3 is less than x. So all my x values have to be -3, less than -3, or equal to. So I'll put that line underneath. And my maximum value for x is +5. So I can say 5 is also the greatest. So x has to be less than 5 or equal to. Sorry. So I put a line there. So basically what I've said there is my x is between -3 and 5, but we know that there's no values in between these numbers, right? There's 3, 4, and 5, but there's no 3.5 because there's no line. So that means x is only going to be integers. So you can say x is equal to integers. So that way you're saying it's not, there's no 1.1 or 1.2, it's just 0, 1, 2, 3, and 4. And then we can do range. And the range, again, we can write down our values. So I'm just going to erase that. So if we look at y values, we're basically looking at what y values does this represent. So if you come across here, we have y is 0, y is 1, y is 2, y is 3, and y is 4. And all of those end up on those integers. So we can say y is going to be, well, the lowest value is 0, and there is a y value that's equal to 0, and the largest value is 4, and there's a y value that's equal to 4. And in this case, it's kind of rare. Usually we deal with lines. Y is equal to an integer. Hopefully that makes sense. Let's do the next one. I might erase this. Actually, you know what I think I can do? Check this out. Circle. Oh, no. Hang on. There we go. I'm going to grab all of this. And then I'm going to make it smaller. Oh, I missed some. That was a good try, though. Okay. Hopefully you got that down. If not, rewind the video. So now we're going to start with graph B. We have domain and we have range. So the domain is all the x values. So in this case, we have a line. So if you look at just this x axis, that line covers from this point all the way across up until +5, but not +5. So that circle right there means that the line goes up to 5, but not 5. It'll be 4.9999999 forever, but it won't touch 5. So those are all the x values. So in order to write that, I can say, well, my low limit is -3. And then I say that has to be less than any x value. That's part of that line. And equal to that, because that dot represents it going right up to -3. Any value has to be less than 5, but I don't put that line underneath because it's not going to equal 5. And in this case, x and y aren't integers. There's all these values in between the integers. So we are going to use x is all real numbers. So now I'm going to look at the y values. Let's look at the y values here. Just going to erase this. So range is all the y values. So you can see if you look at what y values are represented by this function, by this line, we start right here, and it covers all of the values down to there. Right? If I were to trace this across, that would be at 0, and this would be at 4. There's values all between there, but there's nothing up here, and there's nothing down here. So that is going to be, well, what's our low limit? 0. We have our less than sign and equal to, because on the left side of the graph here, it equals 0. That should be a y. And then our upper limit is 4, and it's also equal to it because the line touches right up to 4. And y is all real numbers. And that's how you do the domain and range of a line, and that's how you deal with the circle with like an empty dot. That means that it's not equal to, it's just less than. Okay, I'm going to try to make this smaller again. Okay, so, oh, here we go. Take it all, fantastic. Haha, learning technology. Oh, that did not work. One more try, quick. It looks like it should be working. There we go. That made it too small now. Okay, good. That's fine. As long as you got that down, that's good. Okay, so now we have a similar function, but we have these arrows on the end, and that means that this function is going to go forever this way and forever this way. So let's start with the domain. The domain is all the x values, and it's going to be the set of numbers. Well, if this number goes forever this way and forever to the left, it's going to cover every known x value. We're always going to be able to, so if I was going all the way up to x is 100, I could trace that, I could go straight down and find that function eventually down here. I can do that for x is 1,000,000 and x is 1,000,000,000. So basically, in this case, this is the best case. You can just say x is all real numbers. You do your x, your e, and your r. That's the best one. Now we can do range. So range is going to be y's, and you can see that the y values, if we cover the y values, so the maximum is going to be 4 again. And if we follow it all the way down, it's going to go forever, because we can always find, if we say at x is -5, we can go over and find the function. And we can go either way, actually. At x is -1,000,000,000, we could, if we were all the way down, we could go over and find that function all the way down here. So the y has an upper limit of 4, but no lower limit. I don't know why that erases. So we can write that by saying, well, in the range, y has to be less than or equal to 4. That's it. Y has to be less than or equal to 4, and then we put our little bracket. Y is all real numbers. So that's the only limitation there. X had no limitations. Y just can't be above 4. That's it. That's domain and range. Maybe I'll do one more example, and then I think that'll be it here. Yeah, just gonna do one more example. Actually, you know what? Maybe we should do this in class. I think we'll do this in class, and that way we'll learn a little bit better and learn together. All right, thanks for watching. Don't forget to like and subscribe.